differences between the sexes, so between male and female and intersex, and we'll look at some of those brain differences. And this is basically illustrating sort of sex steroid hormone effects. They affect not only the body and the development of the reproductive system that we've already talked about, the anatomy and physiology of the reproductive system, but those hormones actually affect the brain, okay? They affect the brain and a lot of other organ systems and cells throughout the body. So we're going to go through those. And this is what I sort of trippily refer to as brain sex. Everybody goes, brain sex, what's that? That's not, we're going to talk more about the other type of sort of chemistry and attraction and sexual attraction later. But this is specifically referring to differences between the sexes regarding the brain. Okay, so we talked about reproductive anatomy, now we're switching to the brain. This looks like it has a lot going on here. You can read this text that goes along with this. This is from a supplemental chapter that I've already given you. There's 3, 6, and 16, and 8. This goes through the effects, organizational versus activational effects of sex steroids on the brain. Some of these effects happen in utero. Okay, so while the embryo is developing and the fetus later is developing, it is affected by what steroid hormones are there or not there during that period of time. So we refer to this as organizational, organizing the brain in either a male way or a female way. And then later when the brains are exposed to those later in the juvenile or in the adult, that's the activational effects of these hormones, okay? Organizational, this is looking at, okay, so the ovaries, no testosterone. So in this case, this is a review. There's no TDF, right? There's no testis that develops, testes, right? Because there's no T. Cross the T off. None of those. There's ovaries. No androgens, okay? So in this situation, the female brain and organs are organized. They're not seeing testosterone, okay? Then later, in puberty and getting into the adult stage, when the brain is exposed to estrogen, it gets activated in terms of a female response. Different parts of the brain, they sort of get feminized. So now they have the female response. If androgen the brain is exposed to androgen, it's not activated or only partially activated, so there's little to no sort of male response. So organizational means sets up the parts in the brain and everything to be able to respond to that hormone later in life, puberty, and in the adult. Activational is when you're actually exposed to it again later in life, and you have either the male or the female sort of anatomy and response. So the male organized, of course, has all these factors, has the testes that develop, gets organized in the male brain way. So when estrogen comes later, there's little to no female response, but when androgen comes later, there's a male response or a male output that comes at the level of the brain. And then this is if there's only activational effects. That means there's testes or ovaries, either testosterone or no testosterone, it doesn't really matter. It's not male or female organized, it's just like this in everybody. And then later when there's estrogen, there's a female type response. Or later when there's androgens, testosterone, there's a male response. So there's certain parts of the brain and organ structures that are either organized and activated, or they're just activated. And they respond to those hormones later in sexual maturation or puberty and in the adult. All of that is to say, sex steroids are absolutely critical for helping set up the organizational and activational effects on the brain, and how that person is going to have responses and even think and have some slight cognitive differences between the two. We'll go over those. So this illustrates some of those biological sex differences. I'm not talking about gender roles. I'm talking about sex differences, right? If I look at a male and I look at a female, these are some overall differences. Males have slightly bigger brains, and I always get some of these students are like, ooh, look at that, it gets all. But we're going to go through them sort of systematically. Males have bigger brains, but females have slightly more brain neurons. That means per square, centimeter of brain mass. So here's the human brain. We have this in lab, right? We can do a sagittal section where we kind of open it up. So all that's a little sagittal cut right down the middle. All the outer part is sort of cerebral cortex. That's kind of higher brain function, cognitive function. So overall, the brains of males are slightly bigger. Now, you might go, well, males are bigger though, right? Their body size. Even if we count for the increase in body size, they're a little bit bigger, okay? The number of neurons is slightly higher in female brains, so even though they're a little bit proportionally smaller, there's more neurons per square centimeter. Language is actually processed by both cerebral hemispheres in females, and if we look at males, it's predominantly or only processed in the left cerebral hemisphere. So these are really significant because we take the brain apart and we look at the middle. The brain actually has a big fissure that goes down the middle. It separates it into the right half and the left half, or hemispheres. There's something called the corpus callosum, and it looks just like this big sort of horseshoe shape in there, that big white thick set of tracks. It's on both sides. It connects both brain halves together, allows them to communicate and talk back and forth. There were earlier studies that said the corpus callosum, this middle segment that connects the two sides of the brain, is thicker and bigger in females compared to males, but there's been a lot of conflicting evidence about that. Some say, well, a certain part of the corpus callosum is bigger in females than in males. Others went, nah, not really. We looked at a lot of different studies. We did a review. It's not that much different. But we know whether the anatomy of the corpus callosum is truly bigger in females than males. That's still sort of, the verdict is still out on that. But we know that there's more crosstalk between the two halves of the brain in females compared to males. Okay? So the lateral communication between the two sides, at least for language and communication processing, is more lateralized in females, so crossing between the two sides. Okay? This actually goes along with females have more integration of the right and left cerebral hemispheres. So communication back and forth, not just predominantly one side at one time, but kind of more lateralization or integration of left and right hemispheres. There's also better recovery in females after stroke. Do you guys know what a stroke is? Okay? Stroke, you have they call it a cerebrovascular accident. It's a blood vessel serving a certain part of the brain, ruptures or basically gets dysfunctional, and that can no longer serve blood and oxygen to that region of the brain. So there's a disruption to flow or a hemorrhage in that area. And that prevents, a lot of times, it causes death of neurons and damage and destruction to that area of the brain. Okay? So if it happens to a female, there's usually better recovery to speaking and language after a stroke than there is in males. And it's likely due to that integration or cross-processing between the right and left cerebral hemispheres. There's also some limbic system differences. Do you guys know what the limbic system is? Limbic system is like the emotional side of your brain. It actually has the memory, emotions, experiences, all that wiring is in there. There's a whole bunch of different structures. We'll look a little more at them later. But hippocampus, amygdala, the thalamus, the hypothalamus, olfaction. Believe it or not, your smell is tied right into that as well. You know, when you smell something and it brings back a very distinct memory. You guys ever have that? Like, I can smell a certain cologne, and I'm like, oh my God, it takes me like right back, even made me where I don't want to be. I'm like, oh, never again. You need to not wear that. Woo!
Has the olfactory bulb and the
yes. The olfactory bulb, that's right, Lauren. The olfactory bulbs actually bring the olfactory neurons, your olfactory nerve 1, cranial nerve 1. They bring that information right in through the forebrain, and it fuses on that whole limbic system. So it wires into memory and experience and emotions. There are differences between males and females, slight differences in the limbic system, the size and proportion of those different structures. So there's a little bit of differences there. Females have really a lot higher rates of depression. They have higher rates of migraines, like chronic migraine headaches. Yes, I was talking about migraines last class in my anatomy class. I used to think migraines were just bad headaches, and I was like, oh gosh, don't be a baby, just buck up. I used to be like my little helper for my friends. She'd get a migraine, give me Kathy, give me a triple quad shot, chai latte, no foam, and I'm like, oh god. Just have to go get her caffeine, and she'd be on her desk crying. We were getting our doctorates together. We were lab mates. And then I had a migraine when I grew up, and I almost died. I turned into fetal position, like couldn't have light, couldn't have sound. I felt nauseous. My brain felt like it was getting squeezed, and my eyeballs were like popping out of my head. I had to tell all my little monkey kids, just go eat, just dig in the car, eat whatever you want, just leave me alone. They were making crackers, and here, mommy made you crackers and jelly. Like, I was out of commission for like a whole day. It was horrible. Women have a lot more migraines, chronic migraines, and certain types of neuropathy, Different diseases, things like fibromyalgia, which is like chronic pain syndrome. Women have that at way higher rates than males do. Autoimmune disease also predominantly affects women. It's something like 80% plus of autoimmune diseases affect women and not men. So women in general, we tend to have hyperactivated immune systems. The immune system gets hyperactive and makes too many antibodies and starts sort of attacking and degrading parts of your own body. That's what an autoimmune disease is. I have many friends that have autoimmune diseases. They have RA, rheumatoid arthritis, where it starts to attack your joints, synovial joints like the knuckles, the hands, the carpals. So it's just a thing. It goes along with the differences in disease risks and some of these between the sexes. Males have higher rates of autism spectrum disorder, alcoholism, and addiction disease. And they respond to and metabolize alcohol and drugs differently than women do, including antidepressants. So even their responses to drugs like SSRIs, right, serotonin reuptake inhibitors, is different than in a female body. They metabolize at different rates. Even alcohol, they can metabolize and break down alcohol in their liver quicker than female bodies can. So they metabolize certain drugs, recreational and medical, in different ways. Okay, so there are medical differences between men and women. And I'm going to let you guys read an article later because I feel like there's a lot going on right now before the exam. We'll come back to this later when we talk about disease. The whole last part of the course is all a bunch of fun diseases. And we'll read an article that talks about, you're truly a feminist and you say, okay, we want males and females. I'm a feminist, I'm a STEMinist. But if you truly want, and both, if you truly want, equal treatment, equal care, all these different things, that's great. But sometimes that might actually come at a cost because males and females, in terms of biological disease risk, effects of medications, are different between the two. So we actually have to understand those differences to be able to treat effectively and create better health and wellness for women. Does that make sense? We can't just go, oh, we're all the same, just treat us all the same. Because actually, no, there's a lot of really key biological differences. And if we don't study and learn those differences, we cannot have good medical care for women that experience more of some of these ailments, like autoimmune diseases, for example. That's a great one. We have a guest speaker, and she has an autoimmune disease. And she used to be our physiologist here, and she's retired. She's amazing. She's going to come and talk about a lot of these different things. All right, many, many sex differences in disease risk and the severity of different diseases and the effects of different drugs on the male and female body. So it's important to realize, yeah, we have to sort of respect and understand these differences and not just say, well, we're all the same, because we're not. Yeah, sure.
And in general, for general answer, how does it affect men and women differently from antidepressants?
Antidepressants, it's found that certain types work better in men than in women. So things, if they're just focusing on like serotonin, they work better in men than in women. A lot of women have to have sort of a combination where they're focusing on serotonin and other neurotransmitters like norepinephrine. So the combination, it was realized, wow, okay, a lot of males respond, and a lot of studies, by the way, were done on men. A lot of these drugs and stuff were done on men. And then clinical studies were starting to realize, wait a minute, the females in this population responded totally differently. Okay, we have to start like looking at gender or sex differences because the bodies respond differently. So actually medical researchers really start realizing this. They went, wait a minute, we can't just do this one-size-fits-all drug approach because the bodies do not work that way. So that's a good question. We'll talk more about that later too. Differences in the brain with men and women. There are some sex cognition differences. This is a slippery slope. I always love this material, because it's really interesting. It's fascinating to me. If I didn't study reproductive physiology, I would study neurophysiology, because I love the brain, and I love how the nervous system works, and I think it's so complex and fascinating. But we have to be careful, because these can be a slippery slope. Emphasizing differences instead of similarities, right? Because you can see how this leads to stereotypes, or unfounded, stereotypical stigmas and stuff. So we have to be mindful of that as we're going through and reviewing the facts. So that's why I try to stick to the facts, right? Always bring it back to the evidence-based facts. Here's the brain of a male. That's the left side of the brain. That's the right. So this is an fMRI. That means a functional magnetic resonance imaging. Looking at activity, so oxygen use, right? Metabolism in different parts of the brain. It lights up really bright yellow and red when it's active, and it doesn't show those sort of bright fluorescence when it's not. This is the male and female brain when trying to determine if two words rhyme. So we can do a lot of these communication, linguistic, behavioral studies and just image the brain, right? And see what parts light up and what's involved in those different activities. Whereas you can see, this is both sides, the right and the left, is actually working sort of together to figure out that language question, whereas the male brain in general, it's almost always the left side. It's never the right as well. Okay, so that's a difference between the actual brains in cognition and communication. This is, again, from that supplemental reading. You can read this on your own. There's a lot of acronyms here, but just showing the overall brain. They put crosshatch here, so the occipital lobe, a little specific area of the occipital lobe at the back of the brain. And this is where vision is processed for the most part. So if we look at the back of the brain, it's this whole back part in the very back of the brain right here, the occipital lobe. The brain is chunked into lobes, and all those lobes do different things. The corpus callosum that I pointed out, that thick track that connects the left and the right together and allows them to communicate back and forth and integrate information. Slightly a little bit bigger, the back part of that in the female brain. Although, as I mentioned, some studies have found that that's not always the case. So that's not so concretely established. It seems to be in some studies anyways, it's been reported to be bigger. And then there are some nuclei in the thalamus. So this is blowing this area up, and then this is blowing this area up. Hypothalamus is right here. You should at least know that word. Yes? Hypothalamus, and then it goes to the stalk, and it gives rise to the pituitary. This is the controller of the endocrine system. So it's the neuroendocrine controller of the endocrine system. There's the pituitary stalk, it's cut. So the hypothalamus is already here. There are specific little nuclei in there that are different. This is actually called the sexually dimorphic nucleus of the hypothalamus, the SDN. And that has different size and number of neurons in males and females. I know it looks crazy. You can be a neuroanatomist and still not get every single part of this. Just suffice it to say, there are little small differences in certain parts of the hypothalamus, the corpus callosum, and the occipital lobe of the brain. Male and female differences, biological differences. And then there's been studies where they looked at, okay, let's look at that SDN, that sexually dimorphic nucleus in the hypothalamus. And let's see how many cells are there, because it looks to be different between the male brain and the female brain. And so in here, let's see, we've got heterosexual males are, I want to say the triangles, yes, up over here, mostly over here, just green triangles. The circles are the heterosexual females, so the red is here. They follow this sort of pattern, and this is from birth to 50 to 75, right to 100. So they have a lot of different samples. These come from brain biopsies. Okay, so someone dies, they donate their brain to research medicine science, and we can count, we can look at these things. But these are few and far between. It's hard to get access to these samples. That's why we're still learning things about the brain in human beings. And then homosexual men we have in triangles, or sorry, not triangles, squares. Squares up over here in blue. I guess they put them in blue, so they kind of cluster right there. But what you can see is there's slightly different patterns of these in women, in men, in homosexual men, kind of over here. So there are differences in the number of the SDN neuron number throughout time. And they sort of hypothesize why this difference is. The testosterone in the average man prevents the neurons from dying in the male brain. So the male brain over time, here in green triangles, stays higher throughout time. So there's a different number of neurons, and it's purely coming from the effects of T, testosterone. Keeps those neurons alive longer. So they're actually greater in number in comparing to male homosexual males or heterosexual females. Also, people have looked really heavily at the LH surge components. So we talked about the LH surge, right? The effects of estradiol, they cause a positive feedback response on the KISS neurons. They tell the GnRH neurons to start pulsing out high levels of GnRH. Causes this big fat LH surge that goes like this, right? What does that trigger? Ovulation, okay? And then the luteinization of the follicle that's left behind to become a corpus luteum. Well, there's been a few studies that looked at female heterosexuals, the LH percentage of baseline. So here's percentage of baseline, 25% higher, 50% higher, 75% higher than baseline, bless you. So in females, it goes way up, gets a huge LH surge. In male heterosexual males, there's doesn't go up that high. The LH surge, after they give this little administration, basically it's like GnRH. So it's seeing how they respond to GnRH with an LH surge. Males, kind of small, piddly. A little bit higher in homosexual males, okay? Even sort of in between heterosexual males and heterosexual females. So the LH surge response from the anterior pituitary is different. There's a sex difference there. Okay, does that make sense? Yes. Females ovulate, males don't, right? So there is this component that relates to the reproductive biology there. Females really have a very strong LH surge response. Yeah.
Do you know if there's a reason why they're not also looking at gay women in these studies?
They do. There's a lot of studies. They look. I'll go over a lot of those different studies in that next set, and that is on human sexual behavior and sexuality. I'm not going there yet. I'm just going on brain differences in this particular study. For a lot of these, they do it on whatever they have access to. And sometimes you can't get access to certain people. And actually, I will address something. Be careful when you look at data and you see a bunch of data that makes big, bold claims, and then they have sample sizes, and I'm showing you this data. So sample sizes that are small. Did you just say that? They're small. So you go, okay, there's 12. Okay, there's 12 hetero females, 14 homosexual males, and 7. It's not a big sample size. Did they look at ethnicity? Did they look at race? Did they look at gender? What are all the other confounding variables? So this is just one representative study where they found a difference. It was a statistically significant difference, but I would say the sample sizes are small. Okay, let's make sure we replicate this, and other studies find the same thing. Other studies have found the same thing, but access to the right demographic is not always easy. It's hard to get people to participate in research, trust me. I know. Even when you can't give them a high amount of money either, because that's considered bioethically, like, sort of unethical. You can't, because then what are you doing? If I'm saying, I'll give you $800 to participate in my study. People that are socioeconomically more disadvantaged, it's going to target them, right? I'm going to be having a population that is actually using that in a very bad way. So to maintain good ethics in science, we can't give a lot of money for studies. So a lot of times it's $50, $100, a Visa gift card. It's like lame things that I wish we could do more. But when you breach that line of what's ethical and what's not, it can't be coercion. Do you see that? It can't be coercion. That means I cannot give you an amount that's inexorbitant and where you're like, oh my gosh, I'm poor, I need it, I'll do it. Because I would do it as a college student if I was offered $1,000 to do a research thing, even if it was compromising, I'd probably do it. Because it was money that I needed, right? So some of these studies, sorry, that's honest. Some of these studies, it's dependent on that, right? So it's who they can get. And there's another example of this. Not huge sample sizes, but they started to look at some of these brain differences between heterosexual and homosexual men. There are studies looking at women, but some of these studies really focused on men because they could see the differences very clearly. This happened to be, bless you, a population where they were looking at AIDS and the HIV virus. So they had access to an IRB consented research population that had agreed to the research. We had a reference group, which was just heterosexual, non-AIDS males, homosexual men with AIDS, heterosexual males with AIDS. And then here, same thing, reference group, homosexual men with AIDS, hetero with AIDS, same thing, looking at the volume, and this is a nucleus in the hypothalamus, again. The suprachiasmatic nucleus. It sounds like superfragilistic expialidocious, kids. I don't expect you to remember this. The SCN, suprachiasmatic nucleus, is a specific hypothalamus nuclei, and they found that there's differences in the size, the volume of it, the total number of neurons in it, and the amount of vasopressin that's in the different cells, or the cells containing vasopressin. Do you remember the other word for vasopressin? This is a hormone. And I had you learn this already. Antidiuretic hormone, ADDH. People call it arginine vasopressin or vasopressin, okay? This helps in preventing water loss in the body by the kidneys. So ADH, the number of cells that actually contain ADH in them, in the hypothalamus. Remember, it's released from the posterior pituitary, but it's made in the hypothalamus, as well as oxytocin. These numbers were different, and men with AIDS that were homosexual, they had greater cell number, ADH neurons, and they had more ADH cells that had that within them. That was all statistically significant. So they were higher. For whatever reason, they were higher. They had more of those cells, a greater volume of this nucleus in the hypothalamus, and more of this particular cells that had ADH hormone in them. So you might think, okay, well, there's all these little differences, little small nuclei differences in the brain and different tracts and neurons in the brain, but how they're actually created or how these brain differences are mediated, they can be in lots of different ways. It illustrates all the different kinds of ways that neural networks can be formed in the brain. So organizationally, during embryonic and fetal development, set up, and then activationally sort of activated later at puberty and in the adult. All these little modifications can happen. Notice you can have little different types of synapses. You can gain those synapses. You can have additional spines. And spines on these dendrites is really what allows communication between neurons. So the more spines, the more other axon terminals of other neurons that can attach. That means you have more connectivity or communication between different neurons. Do you know that when you learn and you remember and you use memory and you're learning lots of new material, you're actually increasing the number of spines on your neurons that can help to strengthen and reform and really bolster those synaptic connections. So I'm keeping them good instead of losing them. If you don't learn or you get dementia or you get atrophy in different parts of the brain, you lose these synapses. These spines and these synapses go away. So you don't have that neural connection anymore. You can't process or remember that particular concept. And when you use your memory, it's weird. It's like you're remembering the memories. And then you're remembering the memories of the memories, right? Because it didn't happen. It's just stored in your brain by these synaptic connections, the spines and the synapses between neurons. You can also grow collateral axons that go connect between adjacent neurons. These can be set up in the baby brain, in the embryonic brain, and maintained or affected with hormones throughout life. Okay? And we know this. We can put on different estrogen, androgens. It can affect these different synaptic connections or neural connections. Or even the number of neurons. Some of these will die. Like that one study found homosexual men and heterosexual females had lower numbers of those cells. So if they didn't have testosterone, the number of neurons actually died throughout life, and they had less. So those things change based on sex and hormone exposure. These are some funny things, really. There was even a funnier joke one, but I felt like it was really weird and kind of sexist and pushed the envelope a little too much. But this one is based on some studies that people have done, based on cognition and motor skill differences. And I will say this is not every female or every male that will do good at one of these and not good at the other ones, because there's men and women that do equally well on both sets. And there's men that actually do better on some of these than they do on these, and vice versa, right? So in general, look at a bunch of people and they do these different tests. We'll just look at, okay, women tend to perform better than men on tests of perceptual speed, in which subjects must rapidly identify matching items, for example, pairing the houses on the far left with its twin. So just looking at those and finding the match. Can y'all do that real quick? Mm-hmm. Yep, boom, where's the match? All right, boom, right there, okay. So, and I see some of the male faces puzzled right now. Okay, that makes sense. Female, remember whether an object in a series of objects has been displaced. So if you see an object and then you have to find out the one where it's missing, finding like, okay, here's a bunch of things. Okay, this is the one that's missing. I got to find which one's missing, right? So boom, that one, right? On some tests of ideational fluency, for example, those in which subjects must list objects that are the same color, and on tests of verbal fluency, how quickly you can speak, in which participants must list words that begin with the same letter, women outperform men in general. So putting all these lamp, lag, love, laser, liquid, love, right, all together real quick, women always perform better than men. Not always, but in general, they tend to. Women perform better on precision manual tasks, that is, involving fine motor coordination, such as placing pegs in holes on a board. Some of these, I don't know how they relate to real biological evolutionary things, like putting pegs in a board. I don't know how that's going to really help me with anything, but I'm pretty good at this when I'm pipetting, and I have to pipette in a series of holes. I'm quite fast. So putting a series of little fine motor, getting them all in there sort of delicately and quick. Females tend to outperform males. Women do better than men on mathematical calculation tests, or doing basic things like, despite what people think about math, right? What do you hear about math in men and women? You always hear, men are better at math, women are not, they're more emotional, more intuitive, they're good at the verbal stuff, they're not good at the mathematics stuff. Actually, in these basic tests, women almost always outperform men when it comes to basic arithmetic and calculating stuff and figuring it out, okay? So that's just a little illustration there. Now, the ones favoring men, we got our two guys here now, we're going to have you perform these. I'm just kidding. Men tend to perform better than women on spatial tasks, okay? So visual spatial. Seeing things in space and even be able to kind of see things in 3D and kind of flip them around a little bit, men tend to be a little bit better on that. They do well in ones that involve mentally rotating an object or manipulating in some fashion, such as imaging, turning this three-dimensional object. So if you see it in one plane, being able to rotate it in your mind, go, how would it look on all different sides? Try doing that, it's hard.
Oh yeah, isn't it funny that that's a huge part of the IQ test?
It is a part of the IQ test. You're right, and a lot of these tests are sort of gender biased in many different ways, right? So,
What's the one?
the auditory test, the hearing test?
No, I have to take them for sports when we have to figure out the concussion test. Even those are like based on all the problems on
Right.
the test for men, because half of us get called in and they say you have concussion, what do you do?
You're like, next time you can say, okay, based on brain sex differences, that test is gender biased. And then have him email me. And if you don't want to like stand behind it on your own, just say, he talks about all this. Okay, that's fine. I'll take the heat. I don't mind. So this rotating in space, another one, or determining where the holes are punched in a folded piece of paper will fall when the paper is unfolded. This is kind of tricky. I will say, many women I know too that are artists, they do really well on those. Like they're good at rotating things in space and going, oh yeah, this right here, let's make this. They do the origami, the crazy origami. I was never good at origami, but men are also more accurate than women in target-directed motor skills, such as guiding or intercepting projectiles. So like throwing an arrow, like darts, or like, bow. I actually am learning how to use a bow. I'm pretty good. My aim is actually quite good. I'm better than most of men when I go there. But anyways, so this is in general, better at aiming, sort of a target that's far off. Yeah, Michael.
Actually, I've learned that actually women are a lot better at aiming,
Yeah.
especially in like my cousin, he does
Uh-huh.
like archery.
Yeah,
stuff,
yeah,
and
archery.
Mostly like women are a lot better at like aiming and stuff because they're better at multitasking and they can focus on multiple things.
Right, I could see that. I could see that, because
Guys
actually,
can only focus on one thing.
right, that's true. That is something about the brain as well. I didn't really mention that, but the corpus callosum and the lateral processing between both sides of the brain, it actually makes females, the way that they think and they process is a little more cobweb-like and web-like, where they can do multiple different things at once, whereas men tend to focus on one side, one thing, one focal point at a time. Not that men can't task manage, because many do quite well, but in general, you'll see the female brain light up. It's thinking in sort of a web. So it's doing this, it's doing that, it's nursing the baby, it's doing the thing, it's talking on the phone, it's vacuuming all at the same time. Oh, I've done all those things all at the same time. So our brain sort of, female brain does have more of sort of the web task managing approach in general than the male brain. Yeah.
I would just say I agree with that. I did archery
Right.
throughout high school, and
You
at
were
every
good.
stage, the women were always better than the men. There were a couple stages where
Interesting.
there were no women at that stage.
Right.